for angular velocity and acceleration. Okay. Now you have seen this form before. Let me give you an example. Okay, let me give you a 2D example. Okay, 2D example. Okay. So if we have a vector, a force, let's look at forces. Okay. If we have a force vector, right? This, for example, is equal to 10 kilonewton. And then we have geometric distance, right? So the blue is our geometric distance in x and y component. So if this distance over here is, for example, 7 meters, and over here you have 12 meters, just an example, okay? So what we would like to do is we would like to determine what is our fx and what is our fy. Okay, but we are only given a what? We are only given a distance of 7 meters and 12 meters. Okay, so I'll call this our O, and I'll call this our A. So from here, we have our X and Y component, right? So we know that OA is equal to square root of 7 squared plus by 12 squared, and this will be equal to so I'm going to put it as square root of 193. Okay. So to determine Fy, all I need to do is 12 divided by what? Square root of 193 times by 10 times 10 to the power 3. So this will be equal to 12 divided by square root of 193 times by 10 to the power 3 is equal to 8.638 kilonewton. And then we can determine our fx, which is 7 over by square root 193 multiplied by 10 times 10 to the power 3. Okay. So this will be equal to 5.039 . So it's just basically similar triangles. I believe you have seen this before in 2P, am I right? Okay. So why I put it in forces, because you have seen it before in forces. We are going to do exactly the same for what? We're going to do exactly the same for our angular velocity. This should be alpha. Can you change this, please? And we are going to do exactly as our what? Oh, it's correct. Eugene, wake up. Okay, it's exactly the same as our acceleration, right? You'll get the concept now, yes or no? Okay, so that's what we are trying to achieve. That's why we have to determine our position of AO. Okay. So from here, we are going to find our position okay, of A relative to point O. Okay, so over here, O is our what? Reference point, right? So we are going to use I, J, and k coordinate. So by looking at the diagram, okay, so the I is minus 0.3 I. The J is plus by 0.2. And the K is plus by 0.6 K. Okay. I don't want to take it for granted that isn't it obvious. So the origin is over here, right? So in terms of I, if I call this I now, right? Over here is positive, going back there is what? Negative. So this distance as is going back here, this is equal to minus 0.3 I. In terms of J, right, coming out is positive, going back is negative, right? So in terms of J, this is equal to 0.3 J positive relative to O. And likewise, in terms of K, going up is positive, going down is negative, right? So from here, this is 0.6 K and it's positive. So that's how we get there, okay? Now, in order to relate the position to the resulting vector, the next step we have to do, right, is we have to determine this distance over here, right? So we are going to create a multiplier like what we have seen over here. Okay, we're going to create a multiplier like what you've seen over there. So let me elaborate by trying to tell you what I'm trying to do. So you have U, A, relative to O. You put the minus 0.3 I plus by 0.2 J and plus by 0.6 K. Then after that, you divide by the square root of 0.3 squared plus by 0.2 squared. Okay. Oh, let me put some brackets or not. You ask me, didn't you tell us it's minus? Right? So what you see over here is we are now formulating these terms down here. Okay? We are doing this stage down here, all in one step. So I think I point the wrong one. So if this is y, this is not exactly the same. This is what we're trying to achieve, okay? This is the equivalent. So from here, we get 0.3 squared plus 1.2 squared plus 1.6 squared, square root of the whole thing, 0. So we have minus 0.3 I plus by 0.2 J plus by 0.6 K, and then we divide the whole thing by 0.7. So to tidy things up, we have this expression minus 3 over 7 I plus by 2 over 7 J plus by 6 over 7 K. Okay. So from here, once we have this, we are going to determine omega, right? And then in terms of I, J, and K component. So this in terms to, we know that omega is positive 14, right? And then we are just going to multiply by minus 3 over 7 I plus by 2 over 7 J plus by 6 over 7 K. Okay. So this will be equal to minus 6I plus by 4J plus by 12k. And this is in radians per second. Okay. Before we go any further, usually when you come to a problem like that, you all of a sudden forget what you're trying to determine. That's what happened to me. We are trying to determine at point D, right? What is the velocity at point D? And we also want to find the acceleration at point D. Okay, that's what we're trying to do over here. Likewise, you do the same for the acceleration, angular acceleration, where you have u, a, okay, relative to naught, and then this is equal to, we have given to us, this is 7. So the 14 and 7 is given to us, okay? So I'll highlight down here. Some of you might be wondering where we get 14 and the 7. Okay. So there we put in the 7. Then again we have the same thing. Minus 3 over 7i plus by 2 over 7j plus by 6 over 7k. So this is equal to minus 3i plus by 2j plus by 6k. And we have radians per second squared. Okay. So what we are going to do now, right, is now this is for the rigid body. Okay, and the rigid body represents the plate. Okay, so when it's a rigid body, okay, when it's rigid body, or I'll write down here, okay, when or when, do apologize, at any point within a rigid body, right, at any point within a rigid body, omega and alpha are the same. Remember, we spoke about that, right? That's why we want to understand when it's in a rigid body, right? The angular acceleration and the angular velocity within any points in the rigid body is the same. So if we were to pick a point down here, or a random point down here, a random point here or here, what does it has in common? The omega and the what? And the alpha. Are we clear? Okay. So you have to remember rules like that. Later on, we're going to apply a lot of it. Okay. So the first thing that we are going to determine is we are going to determine velocity at point D. So this is equal to omega cross the radius or the distance, or radius of D from point O. Okay, so let me get the diagram again. So now we have, so the reference is always at O, right? So now we are going to determine what is the direction. Direction is not good enough. The position, okay, of point D from O. Let me write my D properly. All right. So R D from point O is equal to what? Is equal to 0.3 I in Cartesian format, okay? And then minus 0.4 J. Okay. So now you have V D